Okay, in this video I'm going to show you how we're going to construct regular polygons using what I call the rotation method. And it's just using that symmetry concept from the previous video that you should have watched and took some notes on regular polygons. If you haven't, please go back and make sure that you get those. Okay, so rotation. How are we going to take this idea of a point rotating around another point, some angle measure, right, to create a regular polygon? So first of all, to illustrate the concept behind the construction, I'm going to just grab my rotation tool and I'm going to rotate, let's say, B around A. It's asking me how far here, and I'm just going to get rid of it. And since I have a slider here, I'm just going to call the angle alpha. I'm going to rotate clockwise. We're going to go clockwise. So a negative angle measure, really. Okay, but there's my rotated point, right? So now since it's alpha, whatever alpha is, as I slide the value, that's what this angle of rotation is, right? So how can we take that concept and let's build let's say a regular quadrilateral. So quad meaning four sides, regular, all the sides and angles are going to be the same, aka we're making a square here. Okay, so a regular quadrilateral is just known as a square using this rotation method. Okay, so to do that, let's first of all visualize our angle here, our angle of rotation. So I'm going to grab my segment tool and I'm just going to make two radii. These are going to be vertices of my polygon, right? So I'll grab my segment tool. Let's make these babies blue. Stick out a little bit. So here are my two radii. This is really showing the rotation angle here. So if I were to measure this angle, I can show that it's the same angle measure as my slider, right? This is my angle of rotation. So as I rotate B, remember that from the previous video for that heptagon, I believe we had 51.42 degrees, something like that. So if I could get this to 51.42 degrees, what if I can? I wonder if I can do that in this GeoGebra window. 2.8 something, right? Oh, nice, I can do that. So I can get this right at 51.43. It's an approximation of the actual angle measure, but this would be that angle measure that we would use to rotate. If we rotated this point 7 times, that same 51.43, we'd get a regular polygon. It would actually be off a little bit because this is an approximation, not the exact angle. So if we actually used this angle measure, we'd be off just a little bit, which technically really wouldn't be a regular polygon, but for what we would do, it would be close enough. Okay, but we're going to make a regular quadrilateral. Okay, so we're going to make a square using this rotation method, using radii of our polygon here. Okay, so to find the rotation angle, how far do we have to rotate the points to make a square? Okay, so let's do this concept here again, that a full rotation is 360 degrees, right? The point would just rotate right back onto itself. So if we think about a square, how many vertices or how many sides does a square have? Because wouldn't that just be how many equal sections if we think rotational symmetry? How many equal sections there would be? So we would divide that full revolution of 360 degrees by 4, wouldn't we? Since we're making a square, a quadrilateral. Remember, the number of angles of rotation is going to equal the number of sides of the shape. Okay, so if we take our full revolution of 360 degrees, I'm just going to write this over here, 360 degrees, and I divide that by the number of angles I need to make, which is 4 because it's a square, then 4 goes into 360 90 times, or a fourth of a full revolution of 360 degrees would be 90 degrees. So if I rotated this point, say 90 degrees, then this would be a vertex, this would be a vertex, and if we rotated this angle 90 degrees, which I'm going to do that, hopefully. See if I can select everything. I'm going to rotate around the center point 90 degrees. Let's go clockwise. Nice, that whole angle just rotated 90 degrees, and notice this point went to here, this point went to here, right? The next vertex. So let's do that again. We have one rotation angle 90 degrees, another 90 degrees, right? A straight line. Okay, and then let's just rotate this this angle here Let's see. Okay, I'm going to rotate this 90 degrees again, clockwise. And there's my fourth vertex, right? So these are the vertices. These are all 90 degrees in here. That's my angle of rotation. Okay, those all add up to 360 degrees. So now I can draw my sides of my regular quadrilateral here. How do we know that they're all the same? Because we rotated these angles all 90 degrees. These are all 90 degrees in here. Right? I can measure this one. All 90 degrees in here. Okay? And so if the angles are the same, then these sides over here have to be the same, right? Doesn't that make sense? All four of these triangles have to be congruent for rotational symmetry. So we're using that concept to help us construct a regular polygon. Okay, I'm going to show you one more of these, and we're going to take some notes. And I'm going to do this example using our construction tools like you're going to have to do when you get your assignment going. And we'll try to write some steps with this. So just for time's sake, I'm going to keep the sides short here. Let's make a regular triangle, aka an equilateral triangle. All the sides are the same in our triangle here. We're actually going to make one so that we have a measurement we have to meet here. Let's make a regular triangle where the radii are 3 centimeters long. Okay? So how do we do that? Let's write our steps as we do this here. So how do we make our regular triangle here? Basically, how do we construct this regular triangle using the rotation method? Well, just like we did in GeoGebra here, we had to start with a point and a center point, and that segment is really that segment is that distance between them. So all we need to really start with is a segment, right? So I'm going to grab, and let's make since our segment here is going to be a radius, I'm going to grab my ruler here, and we're going to just measure out a 3 centimeter radius. Okay, so the centimeters are smaller than inches, so these would be the centimeters down here. Right. Remember the conversion, there's 2.54 centimeters to an inch. Notice this 1 inch right here. If we go straight down, it's just over 2.5, right? 2.54. So there's 2.54 centimeters to an inch. Helps me remember what side centimeters and inches are. Okay, so we need to make a radius that is 3 centimeters long. So I'm just going to use my ruler here and get to 3 maybe. Oh, sorry. For time's sake, that's 3. Okay, so I used my ruler. I satisfied the radius that's going to be 3 centimeters long. Now we're making a triangle here. So, I'm getting ahead of myself. Let's write our steps. Step 1. I don't like this green here. Let's go blue. Okay, so step 1, make a radius to start with. Okay? So now that we have a radius, we measured it in this case, we need to. If I ask you to just construct a regular triangle, we don't care how long the radius is. You can just make a segment, call it a radius, and use that to make to rotate. Okay? But in this case, we needed it 3 centimeters long, so we're going to do that. Make it 3 centimeters long. Now we need to figure out our angle of rotation, and that's going to be our step 2. So we'll call this figure out rotation angle. Remember to do that, you just take 360 degrees, and we just divide that by the number of sides of the shape, which I'm going to call n. Okay, so I'll just write here n equals number of sides. But this is the main thing here, right here. Okay? So I want that to stand out. I'm going to make it a different color. Okay, so 360 degrees, that's a full revolution. We divided by n, the number of sides, because the number of sides is the same number of angles that we need to rotate. So that's really why we do that. So since we're making a triangle, there's 3 sides, so I'm going to take 360 divided by 3, right? And that tells us our angle measure is going to be 120 degrees. Okay, so that's what we're going to measure with our protractor here. Okay, so I'm going to rotate this. Now, one of the points, we have a segment here. One of the endpoints of the segment is going to be the center of our polygon. The other endpoint is just going to be a vertex, right? So it doesn't matter what's what. I'm going to, though, yeah, I'll just use this side, this point here as my center. So now I have my my starting side of my angle on 0. I know that I need to open up 120 degrees. So if I use my look at my protractor correctly, we're opening up from 0 to 10, so we're going this direction. 120 degrees, which is this line right here. So there's my 120 degree mark. So now I just need to draw that angle. Okay, so we don't know how long, right? We know it's 3 centimeters. We could go ahead and draw this. We could get our ruler back out if we wanted to, and we could just measure 3 centimeters and put a mark there if you want. But if we use geometry and we kind of keep radii concepts going, then couldn't I just make a circle centered at my center that I'm making, go out to a vertex point, which is, that radius is already 3 centimeters because we measured it, and look where the center or the circle intersects our segment. So that truly right here, sorry, I didn't mean to move that. That truly would be our angle right there, right? There's our 120 degrees. So figure out our angle, our rotation angle. So back to our notes here. So we figured out our angle, and then use compass to, oops, not compass, use protractor to measure rotation angle and draw angle. That's the next ray. Okay, and then the next thing that we just did, use the compass to construct a circle to, how should we say this? Use the compass to construct a circle to show radius length. We'll say that. Okay, that's what we just did. And then 5, we just need to repeat until we have made all rotation angles. I don't think I need this anymore. Okay, and then the last thing that we'll do, so let's go ahead and finish this. We have one angle here. If I rotate this one more time, so I'm going to use my protractor. Okay, I'm going to rotate Alright, I'm going to use this side over here as my starting side again. So I'm just going to move my protractor. Okay, I'm going to measure out my 120 degrees again, so I'm just going to do this again. Now we're starting from this side. I want to open up 10, 20, 30, 40, so I got to follow those numbers and follow my 120 to be right here. Right here. Okay, so there's my 120 mark. I'm done with my, oops, dang it. Done with my protractor, and now the last thing that I want to do, finish off my third radius, right? It really goes out to here. I'm just going to shrink it to get that exact radius. So repeat until we've made all rotation angles. So we did. Here's a triangle, 3 angles because there's 3 sides. Step 6, let's draw sides of polygon. And then 7, I'm just going to say, if wanted, erase all guidelines that made the polygon. If you want to get rid of them, okay? But really, your polygon is going to be this, where the sides that connect our vertices, right? There's the actual triangle. This is really what we want. So what I mean by number 7 is, if need be, if you want to get rid of them, we're done with these guidelines. There's our actual regular polygon. Okay, that's the rotation method. So good luck on your assignment constructing some regular polygons.